There are several elements of transformation in what we're doing at the University of Michigan. And I will start with myself. I am not your average professor. I have 31 years of experience in product development and manufacturing with Ford Motor Company and industry. And so without a PhD and without the background in academia, I bring a very different perspective into how to teach systems engineering and how projects are developed and managed in industry today.
In my experience, in order to create the next wave of talent, academia is really transitioning to incorporate more softwares and hands-on tools that students can apply the background knowledge, equations, things that they need to know from those initial governing equations, physics, things like that, but now applying them to the actual tools that they can use to solve problems. And I think academia is realizing that they really need to teach students how to work in an industry environment and what they'll need to know day to day, even like teaming skills, business skills, ethics and things like that, and not just the math and the science as well. And so marrying those two sides of the industry together is really going to set students apart and enable continuous advancement.
Another element of transformation is how corporate partners are helping shape and inform how we run the teachings in the course. So we actually have, for sponsors that are in the lab, we actually have a sponsors working group that meets on a monthly basis, and those corporate partners will share with them what we're doing and what the developments we are undertaking as part of enhancements to the curriculum. We get their feedback, they tell us what they would like to see, and that's another element of how the educational transformation is taking relative to corporate partners helping inform what we teach and how we teach our students. I also want to mention another thing about what corporate partners get out of that. They also get the satisfaction of helping develop and shape the future leaders of aerospace and industry in general going forward. And as a former industry executive myself, that spent a lot of time in recruiting and mentoring and coaching students, I realized just how rewarding and satisfying that kind of thing can be relative to developing future leaders in industry. Siemens Team Center is foundational to what we're doing at the University of Michigan. We house all of our tools in the Team Center environment, and we use several of the Siemens tools in that environment. So we do our requirements analysis and cascade and distribution using the systems modeling workbench. All of our CAD work is done in Siemens NX. We do modeling in Star CCM Plus, Nastran, and then we also use AIMSIM for the multi-domain systems analysis. The students get tremendous value out of the accelerator tools and even the coaching that Siemens has provided in the attempt to integrate those tools into the program.
The Siemens Accelerator portfolio has enabled students to put into practice what they learn in the classroom and apply them to different tools to do realistic applications. And we use the Siemens portfolio across all of our lab sequence, whether it be for CAD and design in NX or to do requirements modeling in the systems modeling workbench. And then we connect all of these different softwares together through Team Center. So the students really understand the trace back from what might cause a requirements issue when they change something in the CAD, and they can really understand the system as a whole.
The really nice thing about this too is that we give the students really deep training in all of those tools. And then we also have the ability to supplement the trainings with real hands-on experience in the lab to corroborate with physical hardware what we're teaching them in these systems tools.
So University of Michigan really sets their students apart. They have really renowned faculty where students can get involved in research. They are so supportive of project teams, whether that's funding or helping them get clearances and get licenses and things like that, and just giving them spaces to work and really encouraging students to get those hands-on skills that they might not necessarily get in a lecture, homework, exam, classroom environment. And they also understand what industry is looking for and takes the steps in order to provide students with opportunities to get those skills. So for example, with this new course series that we're developing, we know that there is a big gap in terms of students understanding product development, project management, risk analysis, and those essential business skills that engineers might not get or don't usually get across other institutions. And so Michigan has recognized this and brings faculty in, brings these course series in order to make sure students have the opportunity and the chance to learn that.
We have had tremendous support from the University of Michigan College of Engineering and the Aerospace Engineering Department in this. we all recognize that this is really just the first step where we said, hey, these are really interesting teachings and learnings. Let's start them in aerospace, see how they work, and then migrate them to other departments within the College of Engineering. We are very excited about the prospects of doing that within the University of Michigan. I would also say, for the competitiveness of U.S. industry, we really would like to see these tools migrated even beyond the University of Michigan. We've been to multiple conferences and talked about what we're doing, and we are open to share anything and everything in order to help migrate these teachings. So it's not just students from the University of Michigan that, now we want to be first and leaders and best, of course, but we would love to see these teachings migrated to other universities, really for the benefit of U.S. competitiveness and industrial strength.